For a standard normal distribution, find P of z less than c equals 0.4082. All right, this one may seem really strange the first time you see one like this. Let's start with what we do know. Normal is the bell curve. Standard means a mean of 0 and a standard deviation of 1, so that your scale just counts in each direction, negatives to the left. Okay. We also know that the total area underneath the bell curve is 1, and that represents the probability of all possible values that could occur along the z-score scale on the horizontal axis. The z-scores are those values on your horizontal axis. The number here is an area. What kind of area depends on the notation, which here we see a less than symbol in our probability notation. So this is a left area. Okay, so I know that I'm looking for a C, a z-score, and this specific z-score has a temporary name of C because we don't know what it is, right? C is like what's this value on the z-score scale. So what we want to do is sketch the left area of 0.4082. So how can we do this? Well, this is us working inversely or in reverse to how we started understanding problems like this. So normally we are given a z-score and we just look for the area. But here they're giving us the area and we're supposed to work backwards to find the z-score boundary. So what we can do is use the z-score table in reverse, and we could also use an inverse function, inverse norm.dist function in Excel. So let's start by making a sketch. It's always super helpful to have a sketch to guide your thought process. Things can get very confusing, and you can think that you've got it right in your head and then find out that you made a careless mistake. It's very easy to do even when you're very experienced. So please don't skip the step of sketching out the problem. So an area of 0.4082 to the left of a boundary. Well, 0.4 is less than half, which means that my z-score boundary has to be to the left of the mean, because if you were to go right down the center, you would have exactly 0.5 on each side. So I know that my c-score is a negative z-score somewhere over there, and that the area to the left is 0.4082. So this means I can use my negative z-score table to look up this left area in the body of the table and work my way out to the z-score. So let's go find the negative z-score table. All right. Now I'm going to search in the body of the table for this area of 0.4082. All right, it looks like the closest is right here. So I'm going to work my way out to the boundaries and get the first digit after the decimal, or the first two digits from the column here on the left. So it'll be negative 0.2. And then I'll work my way up to the top to find the last digit. Negative 0. Ooh, I went way too fast. Negative 0.2. Uh-oh. Did I lose my notes? There we go. And then the last digit is, keep going up and up, 0.03. Okay, so it's negative 0.23. So that's the answer here, negative 0.23. Seems about right, based on where I drew it, more or less. Now I'm going to also use technology to verify that this answer is good. And I'm going to use inverse norm. let's see, I think it's norm.inverse. Norm.inverse. Most calculators with statistical, with the normal function in it will have some sort of normal inverse function where you can enter a probability. Usually it's set up that you're entering a probability to the left. So I'm going to put in 0.4082 and the mean of 0 and standard deviation of 1 because it says that it's a standard normal distribution. And there you see, I get the same answer, negative 0.23. It's also worth showing how to use the absolute value z-score table, which just gives you the area to the left, or has in the body of the table the areas to the left of a z-score. Or I'm sorry, I said that wrong. The negative z-score table and the positive z-score table are set up to show you areas to the left of a boundary, but the absolute value z-score table has areas in the body that represent the smaller shaded side of the total area under the curve being cut by a boundary. So it's always the smaller side you're getting out of this. So if I were to look again for that area of 0.4082, and I look it up in my table, 0.4082, this is the closest thing, and that does coincide with 0.23. But then I would have to come back to my sketch and determine if that should be a negative or a positive. And by my sketch, I can tell that it should be to the left of 0 because of the notation that told me it was a left area, and because of the fact I can see that it's an area that's less than half. So it had to be a negative z-score.